Hi everyone. In this video we're going to be working on 2015 AB Calculus AB free response question number 2. Now this is a question that deals with the calculator and requires one, so if you have one, go ahead and grab it. Let's go ahead and get started. First thing you're going to notice is you're going to see two graphs. One they say is f of x and the one they say is g of x. Also you're going to notice there's two regions. They're probably going to ask us to find an area, volume, cross-section, things like that whenever it comes to a question like this. Good thing is we have our calculator. So it says let f and g be functions defined by f of x equals that and g of x equals that. Let R and S be the two regions enclosed by the graphs of f and g, as shown in the figure above. Now we already need that because we already made this assumption. That's the first thing I always want you to do. Think about what the question is requiring you to do. If you know that, that's half the battle, and you're probably going to get a majority of the points right. Now the one thing you're going to also notice is when you see this question in part A, it says find the sum of the areas. So that means they want you to find the sum of this one and the sum of this one. Remember, when it comes to calculus and they give you two curves, to find the sum of the areas, you have to do top minus bottom of this one and top minus bottom of this one and add these two areas together. Now the only problem is we don't know which graph is which one's f of x, which one's the g of x. We could assume, but we don't want to do that. We want to actually be definite. So what we're going to do is go to y equals 2 and you're going to type in one of the graphs. I'll type in f of x first, 1 plus x plus second e x squared minus 2x. Hopefully we plugged it in correctly, graph it, and you should get something that looks a little bit like that, which kind of shows like it's that graph. So that graph is going to be f of x over here, and it's going to be it's going to be f of x over here. Now the reason why I put that is because I know when I'm finding the area over here, top minus bottom, f of x to the bottom, top minus bottom, f of x to the top for s, okay? One of the most important things. Which then technically means that this is going to be g of x, but I'm still going to graph it so that we can see. So go to y equals 2. For the next line, type in g of x, which is x to the 4th minus 6.5 plus 6x plus 2. Graph it. And it's exactly what we thought, which we thought g of x was the other ones. Okay, so once you have that, your next step is to figure out, this is really zoomed out on our graphing calculator. You want to actually change your windows, because look at it. We're finding the area from 0 all the way to the x value, which is 2. Well, I'm going to change my windows on the x from a little bit left of 0, so -1, and then for my x max, I'm going to change it a little bit more than 2, which is 3. Now I'm also going to change my mins of my y's and my max of my y's, because my min on my y is 0, and my max is a little bit more than 4, so I'll change it to 5. And then when I graph it, it should look a little bit like our actual picture that we have that was given to us. Now the next thing you're going to notice is we have to find the areas of both of them. That's going to be two different integrals. From 0 to some number, which we're going to figure that out, of top curve, which is g of x, minus bottom curve, which is f of x, respect to x. Plus, from this value all the way to 2, which we don't know, we'll figure that out. But our top curve is f of x minus g of x dx. Now our next thing is, let's actually go ahead and find where they intersect. So press second in calc, 5 intersect where it says first curve. Move this cursor so close to the point where they intersect that you think it's on top of it. Once you think it's on top of it, press enter. Second curve, just press enter. Guess, press enter. It's going to give you the value 1.032831 comma 2.401181. I want you to write these decimal places, all of them. And the reason why we're not going to round is because this is not our final answer. So we're going to have to use these decimals to find our final answer. Next thing is, well, that's our bound right here. So I know this becomes 1.30328319. Same thing over here. And then now, once we have everything, clear it out, go to your home page, and let's actually just set up the integral. So this integral is going to be this. Go to math, scroll all the way down to number 9, says the integral from 0 all the way to 1.0 0.0328319. And this is the thing that I want you guys to know. Yes, you have to type in all of g of x minus all of f of x. But you already have your function saved in your calculator. If you went to y equals 2, that's y1, which is f of x, y2 is g of x. So then what I want you to do is, when you have your integral, there's a way to actually get that function and call it out. You're going to press alpha, y equals 2, and y variation, which is traced. Press trace. You see all the list that you had on your graph. Well, because our first graph was f of x and the second graph was g of x, we need g of x. So that's y2. Press enter. Minus alpha, y equals 2. Press trace again. y1, which is f of x. Press enter. And then respect to x, press enter. And we're going to get an area of 0.997426658. Remember, we need these values because this is not our final answer. We still have to add this one. So you could press plus integral again. Number 9, you're going to go from now 1.0328319. Just make sure you plug it in correctly. All the way to our end bound, which is 2. And then remember, f of x. f of x was y1, so go alpha, y equals 2, trace, y1 minus g of x, which is y2, so alpha, y equals 2, trace. Scroll down, press enter, dx, and it's going to add both areas for you. So plus the area that we got here, which is going to be 2.004. And now we can finally round 3 decimal places because this is our final answer. Okay? So that's how you find the area of R plus S. So moving on to part B. Part B says, region S is the base of a solid whose cross-section perpendicular to the x-axis are squares. So all they want is S. Keywords, cross-section are squares. How do you find an area of a square? The base squared, pretty much. So what we're going to do is, well, they already told us our base is S. Well, what is S? Top curve minus bottom curve. From what number to what number? 1.0328319 all the way to 2. That number to 2 of top curve, which is f of x, minus bottom curve, which is g of x. The fact that they told you that this image, this cross section is a square, you have to do this. What is the area of a square? Something squared. That's what you can do. This is that squared. dx. And that's your answer for B. So then your next step is just plug this in. So once again, go to math, number 9, set up an integral, 1.0328319 all the way to 2. Now because we have to square this, you have to put an extra parentheses. Remember, f of x. What's f of x? y1. So go to alpha, y equals 2, trace, y1 minus y2, alpha, y equals 2, trace, y2, and then you're going to close it, then square it, and then that's pretty much dx. Press enter, and you're going to get an area of 1.283 when you round 3 decimal places, and that's a cross section of a square. Okay, cross sections sometimes are a little bit difficult, but you have to remember this, the image. Sometimes they give you a triangle, sometimes they give you an equilateral triangle. You just have to be careful. Okay, sometimes they give you a rectangle. Just think about the area of that shape and apply it here. And the S, the region, is always going to be the area, top curve minus bottom curve. And the reason why it was square is because of the square. A square is the same side times the same side. This times that, which is that square. Okay? So, moving on to C. C was a little bit difficult to many students that past year. So it says, let H be the vertical distance between F and G. Okay. So, in region S. So, once again, region S. Now, I'm going to change colors, but what they're trying to say is this. There's a vertical line between F and G in region S. Now, remember, this line can move anywhere inside of here, so it's changing. And because it's changing, this is why they're asking you this. Find the rate at which H changes to respect to X. Well, you have to agree the heights are changing. Well, how do you find the height of this line, the length of this line? Well, don't forget, the length of this line, how do you even figure this out? It's whatever f of x is minus g of x. Because whatever value I plug in for f of x, it's going to be a little bit greater than this value. So when I subtract these two values, it's going to give me a height. And that's what they're saying. This is h. Well, since I want to find the rate, remember, what is in calculus, what is rate? Rate is derivative. So I'm going to derive this. H prime is equal to f prime of x minus g prime of x. Well, what is f prime of x? We could derive this if we want to, but we have our calculus, so don't even try it. Next thing you have to do is find your derivative and then do what with it? You're going to plug in 1.8. So this real question becomes this, f prime of 1.8 minus g prime of 1.8. And if I find this, this is going to be the rate that's changing in s, the height. And the next thing is just go ahead in your calculator and plug it in. So I'm going to clear everything out. Go to math, scroll down to number 8, and you're just going to type in exactly what you see. Derivative x of f of x. Now remember, there's one thing. Should I type this all in? No, you already have it saved. This was y1. So go to alpha, y equals 2, trace y1. At what value? 1.8. You're going to get a value of that. So 2.116283714 minus, same thing with g prime, but I'll put minus math number 8 dx, and then don't forget this is g of x, so we're going to put in y2, alpha y equals 2, trace y2, press enter. What value do you want to find? 1.8. And what I'm doing is I'm taking this area minus this area, and I'm going to get an answer of whatever that was, which is negative 3.812. Okay? And that is the rate at what it's changing from here to here in region S from f of x minus g of x. Okay? Now, once again, the reason why I did this, h, the height, is determined by the height of f of x minus the height of g of x, this line right here. Because I want to find the rate as this line is changing from all of these points, from this number to 2, it is going to change because rate in calculus means derivative. I have to derive it. F prime minus g prime. Well, because since they're asking you a specific value at 1.8, you plug in 1.8 into here, which is using calculator, take these answers, subtract them, and you're going to get a value of this, and round through decimal places. Okay? So, thank you guys for watching. I hope it helped, and let me know how it went.